Hi there, my name is Jacob Honig and welcome to Cooking with Chemistry. This is my first in-home lab assignment for Chemistry 6BL with Melvin Thomas as TA. We can use chemistry in almost any cooking procedure, but today I'm choosing to make rock candy as I'm a bit of a sugar fiend. Like any procedure, first we need our introduction, our materials, and our procedure, and then a discussion to analyze the results. I will only be making a small amount of rock candy today to demonstrate the chemical principles behind it. This involves making a saturated sugar solution and then having the sugar recrystallize as rock candy. How does this work? Let's find out. For this experiment, we will be using mason jars and a metal pot as our reaction vessels. It's important to clean these as thoroughly as possible to reduce impurities. However, this is a home kitchen. Impurities are everywhere. Our ingredients, or our reactants, we need 1 cup of water and 1.5 cups of sugar. Now I'm also choosing to use a little bit of food coloring just for fun, but try to reduce as much as possible because that is also technically an impurity. I'm going to weigh out the sugar because this is something we can do, and we can take a yield later. First I have to tare the weight on this little bean weighing machine thing that my dad has. Okay, it's tared. 1 cup of sugar. This probably should not be doing this, but my hands are clean. $206 grams and 80 milligrams for 1 cup. And for this 1/2 cup. Now we can begin the first step of our procedure. First, add your water to your pot and begin to boil. I'm choosing to do this on the smallest burner in my house and in a small pot to make sure that the water is heated more evenly, because unfortunately the hottest water is going to be closest to the heating element. And I'm going to make sure that I periodically stir until I see boiling, which should be when I see vapor and a small amount of bumping. So the water's been boiling for a little bit now. I'm using a wooden spoon instead of a stir vane or a glass rod, but as you can see, we're still stirring and it's still boiling. So remove from the heating source and begin to add your sugar at a small bit at a time while stirring. I might need to set something down. Now the goal of this too is to only add in smaller quantities and stir until the sugar is completely dissolved, and then add more. And then you know that the solution is completely saturated when the sugar stops dissolving and forms clumps at the bottom. So I've added the last of my sugar. As you can see, it's kind of forming these clumps, but the solution itself has become slightly more cloudy and viscous. And I think at the end of this, we should have a completely saturated solution. I don't know if you can tell, but I can see, yeah, there's little grain particles in there showing that the sugar's not completely dissolving anymore, meaning that we've reached the point of saturation. So our simple sugar solution is done. A couple side notes. I decided to add my grain. And while I do see some crystals, small sugar crystals still in the water, I want to make sure that my solution is really saturated so that I can get some nice rock candy at the end of this. So I'm going to add more sugar. So I'm giving some time for our saturated sugar solution to cool to room temperature. And in the meantime, I've been making these twine pencil / cool sword things for the crystals to grow on, and this process is exactly like seed recrystallization in other experiments. I'll be saturating the strings with water and coating it with granulated sugar to give somewhere for the seed crystals or the rock candy crystals somewhere to grow. By first soaking it in water, and then I have this small plate of sugar right here that I'm gonna kind of run it through so that it picks up sugar. And it already kind of looks kind of rock candy-esque. But I'm giving some time for it to cool, one for safety reasons so that the glass in the mason jars doesn't crack with the sudden heat to cold expansion if I were to pour it directly in and then put it in the fridge. The other reason is so that this is giving some time for the sugar molecules to interact with each other and get closer to one another so that when they do crash out, they can form a solid crystal lattice structure. An important thing to note is that you want the string barely touching the surface of the liquid here. So I've cut them to be about that length, so I'm only going to pour a very small amount and I'll probably spill. Ooh, it might be a little bit too much. I'll try a little bit less in the next ones. Need just a tiny bit more. Okay, that's good. I'm spilling all over the counter. But okay. As I was doing this, I was hoping to take a yield, which is why I weighed my sugar. But as I'm doing this, I have a lot of solution left in my pan and only 3 mason jars. So I will not be able to take an exact yield. Even if I were to take a yield, it would probably be a very low yield, as there would probably still be sugar still in solution after the rock candy was formed. But I thought it would be nice just to know exactly how much you can expect to make if you were replicating this experiment yourself. As it is, I'll keep the procedure in for future reference. Also, as I was cleaning sugar off the counter, I noticed how sticky and viscous the solution was. So the mixture has changed its density and viscosity based on the interactions with the sugar and the water. Now I've wrapped the tops of my jars, and the procedure I'm following tells me that crystals will begin to grow in 2 to 4 hours if just left in a cool area. And I'd like to see if I can speed that up by placing one of these jars in the refrigerator. The other 2 I will keep out, but I'll check back every 30 minutes or so and check the progress. So I've given this experiment 4 hours to run, which the procedure I was following said it would take about 2 to 4 hours to form. These 2 were outside of the fridge, and this one was in the fridge. And the results are pretty poor. As you can see, this was a pretty poor reaction. Not many crystals formed at all. But on the inside of this mason jar in the fridge, we actually did get some crystals crashing out. The procedure told me it could take 2 to 4 hours, but other procedures I've looked at, including this time-lapse video that I found on YouTube, says it can take up to multiple days for the crystals to condense. And I think my errors came from not using an absorbent enough string, so that it seemed to get wet and soaked, but it didn't. When I looked, none of the green dye had really made its way up the string. But to talk about what happened today, granulated sugar like we use today is sucrose. From its structure, it has many oxygens and hydroxide groups that are ideal for hydrogen bonding, which is why sucrose molecules can hydrogen bond with water, break its crystal lattice structure, and dissolve. Adding heat to the mixture helps more sucrose dissolve by biting its structure and causing wider gaps, allowing more water to break into the lattice and disrupt the structure, which causes the crystals to dissipate. We take advantage of this in the purification technique, recrystallization, very often in lab. When the solution cools, sugar molecules find each other in solution and begin reforming the lattice to form crystals. The sugar-saturated string provides a place for crystallization to occur by providing fully formed crystals in a water medium that allows the solution to be drawn up the string using the capillary forces of adhesion and cohesion. Taken from biology courses, the flow of the saturated solution will go from a high concentration of ions to a low concentration, meaning that the string can't be fully immersed in the solution or the solution won't want to travel up the string. Also, I'd like to thank you to the TA staff for making videos this past year. After this assignment, I have newfound appreciation for your work.